This is section 5.1, which is law of sines. Law of sines is used to solve triangles that are not right triangles. We call them oblique triangles when they're not right triangles. If we have a right triangle, then we can solve it using sine, cosine, and tangent, you know, the SOHCAHTOA stuff. Or we can use usually Pythagorean theorem or something to find one of the legs. But when we have an oblique triangle that doesn't have a right angle, we have to use either law of sines or law of cosines. Law of cosines is section 5.2. Okay, so law of sines is all about proportions. That means the ratio of the sine of an angle over the side that's across from that angle is the same ratio as the sine of another angle across from the side from that angle, which is also equal to the same ratio of, that was supposed to be a gamma, across from the side that's across from that angle. So here we have a proportion. A proportion means that ratios are equal to each other. So we have sine of alpha over A equals sine of beta over B equals sine of gamma over C. Now, of course, that specifically means that side A is always across from side angle alpha, side B is always across from angle beta, and side C is always across from angle gamma. Okay? Law of sines works when we know certain bits of information. The important thing about the information is that we have an angle and a side across from each other. If we don't have an angle and a side across from each other, then we can't use law of sines. We will have to use law of cosines. So when the information that they give us is a side, an angle, and an angle, we can use law of sines. Or if the information they give us is an angle, a side, and an angle, then we can use law of sines. And we'll see an example of why that one will work in just a minute. And then we can also use law of sines when we have a side, and an angle.